Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another video, and this video is how to name ionic compounds worksheet. So this is going to give you the uh, components and the ways to name ionic compounds and write their formulas, in fact, too. All right, so without further ado, let's get to moving here. Okay, so definition of the ionic compound and a brief comparison. Ionic compounds are composed of two ions. A. Ionic compounds are known as salts and therefore dissociate in water to produce ions and consequently conduct electricity. They conduct electricity when in water, which is aqueous, or also they conduct electricity when they're molten, but not in their solid state. First is how to differentiate an ionic compound from a previously mentioned binary covalent compounds. Binary covalent compounds are composed of two nonmetals only. Ionic compounds are composed of a positively charged ion and a negatively charged ion. Typically, that positively charged ion is a metal that's a cationic charge, and the anion, the negatively charged ion, is that of a nonmetal, although it could be a polyatomic ion. This positively charged ion could also be a polyatomic ion. Here are the rules for naming ionic compounds. Number one, an ionic compound is always composed of a positively charged ion. This is a cation, followed by a negatively charged ion. This is an anion. Number two, the cation and the anion are combined together in such a way that the net charge on the compound is equal to zero. This is the central dogma of ionic compounds. Prefixes are never used in ionic compounds, unlike binary covalent compounds. The cation is always written first. If the cation is an element of which will be a metal, then the name of the element is written first. Number one, if the element has a single cationic charge, i.e. a group 1 or group 2 or some specific transition metals, then only the element is written. I'm going to scroll this on up so you get to see a little bit more. If the element is a transition metal that does not have a single cationic charge, then either the common name is used or the systematic name is used. A common name has an ending that indicates the charge on the ion. Example, OUS ending for the lower charge and an IC ending for the higher charge. A systematic name is the name of the element on the periodic table with a Roman numeral to indicate the charge. The Roman numerals are as follows. 1 is I, 2 is II, 3 is III, 4 is IV, 5 is V, 6 is VI, 7 is VII, 8 is VIII, and 9 is IX, and 10 is X. If the cation is a polyatomic ion, then the name of the polyatomic ion is written without any changes. The anion is always written second. If the anion is an element of which will be a nonmetal, then the name of the element is written plus the suffix IDE. If the anion is a polyatomic ion, then the name of the polyatomic ion is written first without any changes. If the anion is a polyatomic ion, then the name, yep, that's correct. Oh, hey, by the way, did you know that you are watching none other than the one and only, the Crazy Hat Chemist? And you're watching this video here on YouTube. I would appreciate it if you give me a like and subscribe and add comments into the comment section. Please, please, please. All right, we're going to flip this sheet of paper over here for some more information on how to name ionic compounds with many examples. Okay, here we go. Um, let's see here. Number 3, example problems. Name the compound NaCl. The first is the cation, which in this case is the element sodium. Therefore, sodium is the first name and no Roman numeral is used since sodium is in group 1, i.e. it only has one cationic charge. That is a 1 plus, and that is it, and that is period. Okay. The second is the anion, which in this case is the element chlorine. Therefore, the root word is used with the IDE suffix, adding to give chloride, combining the two together to give the proper name sodium chloride. Example B, the name of the compound, or name the compound, Ca parentheses NO3 with a 2 outside the parentheses. The first is the cation, which in this case is the element calcium. Therefore, calcium is the first name and no Roman numeral is used since sodium is in group 2, i.e. it only has one cationic charge of a +2. The second is the anion, which in this case is the polyatomic ion nitrate. Therefore, the name nitrate is used since no changes are made to the words of polyatomic ions, combining the two together to give the proper name calcium nitrate. Name the compound NH4 parentheses 2 CO3. The first is the cation, which in this case is the polyatomic ion ammonium. Therefore, the name ammonium is used since no changes are made to the words of polyatomic ions. The second is the anion, which in this case is the polyatomic ion carbonate. Therefore, the name carbonate is used since no changes are made to the words of polyatomic ions, combining the two together to give the proper name ammonium carbonate. D, name the compound FeCl2. Slide this up just a little bit so we can see all of this. The first is the cation, which in this case is the element iron. Therefore, iron is the first name and a Roman numeral is used because there is more than one charge on the iron ion. The charge on this iron is a 2 plus, giving the name iron Roman numeral 2 or ferrous. The second is the anion, which in this case is the element chlorine. Therefore, the root word is used with the IDE suffix, adding to give chloride. Combining the two together to give the proper name of iron 2 chloride. This is the systematic nomenclature, or ferrous chloride. That's the common nomenclature. So depending on what your instructor is asking you to do, common or systematic, or maybe both, then you need to write that down. All right. So here we go with some more examples. Letter E. Name the compound FeCl3. The first is the cation, which in this case is the element iron. Therefore, iron is the first name and a Roman numeral is used because there is more than one charge on the iron ion. As we just noted in the previous example, let me scroll that down right there to keep that there. The charge on this iron is a 3 plus, giving the name iron Roman numeral 3 or ferric. The second is the anion, which in this case is the element chlorine. Therefore, the root word is used with the IDE suffix, adding to give chloride, combining the two together to give the proper name of iron 3 chloride. That's the systematic nomenclature or name, or ferric chloride, which is the common nomenclature name. All right. So we're actually almost done with the rules here, and then we're going to do some more examples besides these ones that I've spelled out actually for you, really. All right. Okay, so just a couple more here, or one more. Name the compound PbS. The first is the cation, which in this case is the element lead. Therefore, lead is the first name, and a Roman numeral is used because there is more than one charge on the lead ion. Remember that ionic compounds are combined such that the net charge on the compound is 0. Knowing this fact and that the charge on the sulfur ion is only one, has only one charge, the lead ion must have the same corresponding charge to yield a net charge of 0 on the compound. The charge on this iron is a 2 plus, giving the name lead 2 or plumbus. The second is the anion, which in this case is the element sulfur. Therefore, the root word is used with the IDE suffix in added to give sulfide, combining the two together to give the proper name of lead 2 sulfide. That's the systematic nomenclature, or plumbus sulfide, the common nomenclature. Rules for writing ionic compounds. Ionic compounds, as stated above, always contain a cation written first, followed by an anion, which both are combined such that the net charge on the compound is 0, with the lowest whole number ratio. This process is opposite that of naming ionic compounds. And again, just as a reminder, you are watching none other than the Crazy Hat Chemist. And please, you are watching this video on YouTube, of course, and I greatly appreciate your like and subscribes. And here are some examples. Here are 10 of each examples. So here we go. All right, so we've got 20 examples in total, and let's see if we can hammer these little babies out. All right, you are watching the Crazy Hat Chemist. That's right, folks. Bing. Okay, so the first 10 are formulas, and we're going to write the names. So first of all, we have a number here. We have a number here. This number is a 1. That number is a 1. So what we're going to do is we're going to take this number right there, this number right there, and I'm going to zoom in on this here so that we get a closer view of each one of these. What we're going to do is we're going to take the bull by the horns and flip and bring the numbers up. So that means that this number comes up here, this number comes up here. That's a 1, that's a 1. Cations come first, anions come second. I need to find this K right here, and I need to find that Cl right there. The K is going to be in the 1 plus category. So really what you need to acquire is you need to shoot me a comment in the comment section with your email, and I will send you this as a PDF. And this is the charges on ions and oxidation numbers. It's a whole giant sheet of paper with all the ions and charges on them, something that I've designed and made myself here. So, for example, what are we looking for? We are looking for a 1 plus, and it's a K with a 1 plus. What's the name of that? Potassium. So I'm going to write down the word potassium. Cool, awesome. And then I'm going to find Cl with a 1 minus. So where am I going to find that Cl with a 1 minus? That is a -1. That's a Cl1 minus, and that is chloride. Chloride. So the name of KCl is actually potassium chloride. All right, let's try another one here. There is a number right down here. That's a 1. There's a number here. That is actually a 2. I'm going to take the bull by the horn, flip, and bring these numbers up. That gives an Mg with a 2 plus and an I with a 1 minus. So I'm going to look on my ion sheet, and I'm going to see if I can find these ions and their charges. So I'm gonna look in the 2 plus category. What am I going to find? Mg 2 plus, that is magnesium. So I'm going to write down the word magnesium. And then I'm going to find I in the 1 minus category. So I'm looking in the 1 minus category, and there is my I 1 minus, and that is iodide. So the name of this MgI2 is magnesium iodide. All right, let's go for another one here. And I'm going to highlight this number and that number. I'm going to take those two numbers, flip and bring them up, flip and bring them up. That gives me this Al as a 3 plus, that O as a 2 minus. I'm going to look in the 3 plus category for the Al 3 plus. That is aluminum. I'm going to write down that word of aluminum. And then I need to find in the 2 minus category of the element with an O. So here is the 2 minus category. There's an O with a 2 minus. What is that? None other than oxide. So the name of this compound is aluminum oxide. All right, fantastic. Now what we're going to do, Now, this is the first time that we actually have a polyatomic ion. A polyatomic ion is when you have an ion with two capital letters. So I'm going to put a parentheses around every polyatomic ion. There's a number here, that's a 1. There's a number here, that's a 1. I'm going to take these numbers, flip, and bring them up. This is a cation, that's an anion. So now I need to find this polyatomic ion, SO4, and I need to find the Zn. I'm hoping that the Zn is in this 1 plus category, but I cannot find it. So then I'm going to go to the 2 plus category, and I do find the Zn. It's zinc. It's a 2 plus. So I'm going to write down the word zinc. Now notice that that was a 2 plus, and the ratio is 1 to 1. I need to keep that ratio as 1 to 1. So what must this charge on this anion be? A 2 minus. So I'm going to look in the polyatomic ion section. Those are ions composed of two elements, and I'm going to look in the 2 minus section here of my polyatomic ions, and I'm going to find SO4 with a 2 minus. That's SO4 with a 2 minus. That corresponds to sulfate. So the name of this is zinc sulfate. Perfect. I'm going to take this number right here and this number right here. That's a 2 and a 1. I'm going to flip those numbers, bring them up. That 2 comes up over here. This 1 comes up over here. That's a cation. That's an anion. I'm going to find Li, that is a 1 plus. So I'm going to look on my sheet of paper here. I'm going to find an Li that's 1 plus. That's a lithium. So lithium. And then an O with a 2 minus. We've already done this one actually. And in the 2 minus category, there's an O that's a 2 minus. That's called oxide. So the name of this compound is lithium oxide. All right. Fantastic. All right, let's do the second half of the naming of the compounds, and then we can get to the second half of this worksheet. Okay, the next one here is CuCl. There's a 1 there. There's a 1 there. I'm going to circle these two numbers, flip and bring it up, flip and bring it up. That's a 1 plus. This is a 1 minus. Okay, I'm going to look in the 1 plus category, and I'm going to look for a Cu. Sadly, I cannot find in the 1 plus category a Cu. So now I'm going to have to look somewhere else. Okay, and I'm going to have to look on the transition metal cations, and I can find the Cu right here. That is a copper Roman numeral 1 or cuprous. So I'm going to write down the word copper, Roman numeral 1 or cuprous. And then I need to find the Cl that's a 1 minus. In fact, we've used this one already before, and in the 1 minus category, I'm going to find the Cl, and that's called chloride. Because this is a transition element with, that is the copper as a transition element with more than one charge to it, you can have it named in the systematic name of copper Roman numeral 1 chloride or the common name of cuprous chloride, either one. All right, let's do the next one here, and that's a 1 right there. That's a 2 right there. That's going to flip and come up. That's a 2 plus. This is a 1 minus. We already did the chloride, so hopefully that makes sense. The other one is a copper. We couldn't find the copper other than in the transition element category, and this one is the 2 plus ion, and there it is right there. That's a copper 2 plus or copper Roman numeral 2, and that's cupric. So I'm going to write both of those down. Copper, Roman numeral 2, or cupric. And then we already did the Cl, that's a 1 minus, the Cl in the 1 minus category, and that's a chloride. We already did that, so it's chloride. So there's two possible names here for this compound. It's either copper Roman numeral 2 chloride, that's the systematic name, or the common name is cupric chloride. All right, fantastic. All right, the next one here, we're going to put a parentheses around this polyatomic ion and a parentheses around that polyatomic ion. The 1 and 1 is right there. I'm going to flip them and bring them up. That's a 1 plus. This is a 1 minus. Notice that this is a polyatomic ion. And there is only one polyatomic cation, and that is it. And that is right there. That's NH4. That's called ammonium. So I'm going to write down this word, ammonium. And then I have NO3. That is obviously a polyatomic ion. It's a 1 minus charge. I'm going to see if I can find that as well. And NH3 in the 1 minus category. So I need to find the 1 minus category here on my polyatomic ion sheet. That's NO3 minus 1. That is called nitrate. Ammonium nitrate is the correct name. All right, the next two here are very similar. Notice that this is going to be a 1 here. This is a 1 here. I'm going to take this 1 and that 2, this 1 and that 3. I'm going to flip those numbers up. This is a 1 minus, that's a 1 minus, this is a 3 plus, and this is a 2 plus. Okay, so that means I have an element with two different charges on them. That must be a transition metal cation. So I'm going to look for the 2 plus and the 3 plus. Here is the 2 plus, and I'm going to put this in two different colors. That's a yellow for the iron Roman numeral 2, which is ferrous, or in blue, which is the iron Roman numeral 3, and that's a ferric. So this one here is iron Roman numeral 2 because of that 2 plus charge, and or it's ferrous. And then this one, because of the 3 charge, is iron Roman numeral 3, or it's ferric. Notice on both the copper and the iron that the higher charge has the ick and the lower charge has the us. All right, now I need to find this OH that is going to be a 1 minus. That's obviously a polyatomic ion because it has two capital letters to it. It's one of the most common polyatomic ions. It's OH1 minus. Where are we? There we are. And that's called hydroxide. So we got the name here for both of these. Iron 2 hydroxide or ferrous hydroxide or iron 3 hydroxide or ferric hydroxide. Remember, the Roman numerals correspond to the systematic nomenclature, and the OUS and IC correspond to the common nomenclature. All right, so we've done half of the example problems. Let's move on over from formula to name. We're going to move from name to formula right now. So let's do that right now. So here we go. And let's see what we got here. Oh yeah, folks, and just as a real quick here, you are watching none other than the one, the only Crazy Hat Chemist. And please like and subscribe, give me some comments. And if you want that ion sheet, please let me know. Send me a comment in the comment section that you want it. All right, this next one here, we're going to go from the name sodium hydroxide to the formula. So we're going to look for sodium on our ion sheet. And here it is. It is right here. There's sodium. And what is it? Na1 plus. So I'm going to write that right up here, Na1 plus. And then hydroxide, we just did that on the last naming one as well. That's a polyatomic ion. That's a hydroxide that corresponds to OH1 minus. So that's OH1 minus. And I had mentioned this already earlier with the other problems, but what we're going to do is we're going to take these numeric values. We're going to take the bull by the horns this time, flip the numbers, and drop it down. So that means that this 1 is going to come here, that 1 is going to come here. We're going to write NaOH because we don't write ones. There's actually an imaginary 1 right there. There's an imaginary parentheses around this and an imaginary 1, but we don't write ones. Just like when we write the variable x, there's actually a 1 in front of that as a coefficient and a 1 as a power, but we don't write those ones either as the coefficient or the power. If those coefficients are powers, like 3x squared, if those numbers are other than ones, then we most certainly do write them. All right, let's do the next one here. That next one is barium hydroxide. I'm going to find barium. And here is barium. That corresponds to Ba2 plus. Ba2 plus. We just did hydroxide, so I'll take the liberty of writing that down. We're going to take this number here, that number there, take the bull by the horn to flip, bring it down. Booyah! And we're going to get BaOH. And there's a 2 outside. But we must have this parentheses that is absolutely critical. because that OH is a polyatomic ion. And when you have more than one of a polyatomic ion, you need those parentheses. The next one is tin Roman numeral 2. That Roman numeral 2 lets you know that it is a transition metal cation. So that is tin Roman numeral 2. There's tin Roman numeral 2, otherwise known as stannous. That's SN2 plus. So that's SN2 plus. And then fluoride. Fluoride is a halide ion. That's right here as fluoride. That is an F with a 1 minus. So F1 minus. I'm going to take the bull by the horns of these two numbers, flip them and bring them down. I'm going to get SnF2. Then the next one is tin 4 iodide. That Roman numeral 4 lets you know the charge. We just did a tin 2, so it should be a Sn and a 4 plus. But let's just verify that on this sheet of paper here. There is tin Roman numeral 4. That's Sn4 plus, which is also otherwise known as stannic. And then it is iodide. Iodide is right there. That's an I1 minus. I'm going to write that down, I1 minus. I'm going to take these two numbers, flip the numbers, bring them down, and I'm going to get SNI and a 4. Whew, all right. Then it's cadmium nitrite. So cadmium is right here, and that's CD2 plus. And that's Cd2 plus, and then nitrite. Nitrite is a polyatomic ion. There's nitrite. That's different than nitrate, by the way. There's a single letter difference and there's a single number difference. That's NO2 minus 1. That's NO2 minus 1. I'm going to take the absolute value of those two numbers, flip, bring them down. I'm going to get Cd parentheses NO2 and A2. That's cadmium nitrite. All right, we only have 5 more problems to do, and then we're going to be done with this worksheet. And then, of course, after this, you're going to watch all my other videos within this unit, because I have many, many more examples. So we're going to slide this over. And, of course, the crazy head chemist. That's where we're at, baby. The next one is calcium chlorate. So I'm going to find calcium here. And where is calcium? Calcium is right there. That corresponds to a Ca2 plus. Ca2 plus. And then chlorate, that is going to be a polyatomic ion. That is chlorate. That corresponds to ClO3 1 minus. ClO3 1 minus. CaClO3. I'm going to take the bull by the horns, absolute value of those. Flip and bring it down. I'm going to need a parenthesis since I have more than one on that polyatomic ion. The next one is potassium carbonate. I'm going to find potassium. We've done potassium already here today. There is potassium. That's a K with a 1 plus. That's a K with a 1 plus. And then carbonate is a polyatomic ion in the 2 minus category. That's carbonate, CO3 2 minus. CO3 2 minus. We take the absolute value of these two numbers, flip the numbers, bring them down. I'm going to get K2CO3. There's an imaginary parentheses around this carbonate, but the number is a 1. So I don't write the 1, I don't write the parentheses. All right, this next one, I've got cobaltous and cobaltic, and then they're both chromates. So I need to find cobaltous and cobaltic. So those are transition metal cations, and those are right here. Here is cobaltous, and here is cobaltic. That corresponds to cobalt Roman numeral 2 for cobaltous, and for cobaltic, it corresponds to cobalt Roman numeral 3. The 2 and the 3 on the Roman numerals correspond to the charges, and it is a C and an O. So that's CO2 plus and a CO3 plus. Notice that that O is a lowercase o, not a capital O, because that would be a problem. That would be completely nothing. Then we have chromate, and that is a polyatomic ion. We need to find out where chromate is. Chromate is in this 2 minus category. There's chromate, not dichromate, but it's CrO4 2 minus. CrO4 2 minus, CrO4 2 minus. We're going to do this one here first. Flip these numbers, bring them down. We're going to get CO2, CrO4 parentheses, and a 3. And let's slide that over so you can see that. This next one is a COCRO4. And actually, what we have is a 2 right here, a parentheses, and a 2. But what we have to do, one of our other rules here that you're going to learn right now, is that you have to reduce the numbers when you can. So I'm going to erase those 2's because they drop out. Very important problem. Our next one here and final problem here of today is ammonium oxalate. Ammonium is the only polyatomic cation. That's ammonium. That's NH4 1 plus. NH4 1 plus. And then oxalate is a polyatomic ion in the 2 minus category. There's oxalate that corresponds to C2O4 2 minus. C2O4 2 minus. I'm going to take these numbers right here, flip them, bring them down, and I get NH4 parentheses 2 C2O4. And that's the end of that one. That's a pencil drop. And just as a real quick reminder here, you are most certainly watching The Crazy Hat Chemist, and I am the source for all your awesome chemistry needs. Right here is the ion sheet. So if you are looking for this ion sheet, which you probably are, you should send me a comment in the comment section and send me your email, and I will send you this as a PDF format. If you're in a higher level of chemistry, I have one that has more information than just this one does. So that would be for like honors chemistry or college. I hope you have a fantastic day and enjoy your afternoon. I'm the Crazy Hat Chemist. I love you and have a great day. Talk to you later. Bye for now.